Let us look at an interesting demonstration of Bernoulli's principle. I have with me a sheet of paper. The sheet of paper is supported by a pen here. Now if I blow air onto this side of the sheet of paper, the force of air molecules would make the sheet of paper rise up like this. That's quite intuitive. What if I blew air over the sheet of paper? Would the sheet of paper still rise? Let us see. I'm placing the sheet of paper comfortably below my lower lip, and if I start blowing air, surprisingly, the sheet of paper still rises up as if there is a force being applied from this side. But we didn't actually blow any air onto this side of the sheet of paper. So how do we explain this? This can be explained using Bernoulli's principle. Let's see how. Now, according to Bernoulli's principle, when an ideal fluid undergoes steady flow, its energy density is uniform. That is, its pressure energy per unit volume plus the potential energy per unit volume plus the kinetic energy per unit volume. This sum is same at all points of the ideal fluid in steady flow. Let's consider 2 points, one on each side of the sheet of paper. One on the upper side of the sheet where I am blowing air, let's call it A. Another point on the lower side of the sheet where there is no air being blown, let's call it B. Assuming air as an ideal fluid in steady flow, according to Bernoulli's principle, we can write the pressure at A plus rho g, height of the point A from the ground, plus half rho, speed of air at the point A squared, must be equal to pressure at the point B plus rho g, height of the point B from the ground, plus half rho, speed of air at the point B squared. Now height of the point A from the ground is almost equal to the height of the point B from the ground. So we can cancel out these two terms and we will effectively be left with P plus half rho VA square equal to PB plus half rho VB square. Now since I am blowing air over the sheet of paper, definitely the speed of air flowing through the point A is greater than the speed of air flowing through the point B. So VA is greater than VB. Now if VA is greater than VB, then to balance the equations, PB must be greater than PA. What does that mean? That means the pressure of air below the sheet of paper is greater than the pressure of air above the sheet of paper where air is being blown. So if the pressure of air at B is greater than the pressure of air at A, then the sheet of paper experiences a greater force from below than from above. This is what causes the sheet of paper to rise. So this is how we can explain the rising of the sheet of paper by using Bernoulli's principle. Do you think you can explain the floating of this ball using the same principle? Go ahead and try it. For more interesting science and physics content, subscribe to my YouTube channel, AxPhysics. Thanks for watching.